Greetings, my name is John Hernandez, and with my partner Alejandro Rodriguez, this is our project Van Gogh's Ear. Here is the outline of a project with the introduction of the problem, the deliverables and milestones, the expenditure and budget. The main body is comprised of the system, its specifications, design alternatives, architecture, a video of it working, assessment and impact of the project, and a conclusion that has the summary of the project, including what's next, and a Q&A session.
As John pointed out, we're going to be kicking off with the introduction for Van Gogh's Ear, the project, and the outline of the problem, our deliverables, and the expenditure and budget following this slide. For the problem we have is musical instrument learners struggle to maintain interest in learning music instruments on their own. One key reason for this being the lack of variety for music talk and learn in music education institutions, and another being the lack of feedback loop at home from professors. Another compounding reason is the lack of accessible music transcripts for commercially available popular songs thanks to fair use laws and their restrictions on copywritten laws.
Now for the deliverables and milestones of which were passed, the first being essential research completion by September 26th, the system design, diagrams, and requirements delivered on October 11th, the system modules implemented and tested by November 16th, these modules integrated by December 8th, and these modules being demonstrated on the 12th of December. Here we have our total expenditure and budget, our budget being an expected cost of $20,074 and a final actual cost of $20,061.98, making the expenditure 0.0599% under budget. And now we will talk about the system and its attributes. Here we have the specifications of the system, of which the first is the system compares tablatures, and it is tested against automatically generated tablatures from user input, and from these is attained a degree of precision between these tablatures. For the next specification, the system can play chords for the user, and this was tested by having a user-generated text input to request an internal chord audio file, and this attains that file if it exists from the local database. The third of the specifications is that the system can allow the users to see generated tablatures, and this is tested from a user selected file from a previously stored tablature, and what it attains is a view of this previously generated tablature. The last of these is that the system can delete internally stored tablatures tested on deleting entries on the local database using the SQL queries, and this is attained by showing the removal of selected entries on the local database. For the design alternatives overview, we have Java as our Android application development language because all of the APIs and documentations were written in Java, and we believe all of the best functions are in Java that will help us the most. For the machine learning module, we have Python, of which it has been used in this field for extensive research along with signal processing, and for machine learning frameworks, the library of TensorFlow because it is the most flexible against Theno, PyTorch, and Scikit. And for the database query languages, we've chosen MySQL because of how lightweight it is and how it is the only one implemented in Android application development. And now for Alejandro, who will talk about the system architecture.
Here we have the essential diagram for the system architecture, in which we see the major modules and their interactions with one another with respect to the most important processes found within our application. So we see that the GUI interacts with most of the other services via the device manager, and inside of which we have a file manager service. And for any interactions with files directly, we use the IO device manager to interact with the database, to query and to insert new data into our system. Finally, passing some of the available GUI functionality for, say, microphones through the device manager into the audio preprocessor, which feeds it into our audio classifier for detecting chords or generating our tablatures and feeding those back to the GUI via the IO device manager. Here we have the neural network architecture. In particular, we use internally the convolutional neural network, and we utilize this one because we want to maintain spatial information and reduce the dimensionality of our data while being able to classify multiple classes, quote unquote, of targets that we want to identify. In our case, would be different chord classes. So some of the cons include time to train the model growing proportional to the quantity of targets, the accuracy dwindles with each new target we want to detect, and it also requires an extensive dataset available with varying degrees of noise or ambient noise or different variations in duration for chords. Here we have a video of a brief overview of the core system interactions from a user standpoint and what processes we expect a user to take when they want to pick a file to be processed in detecting their chords automatically in our system. Moving into project assessment, here we have first and foremost the project adjustments. So we reworked the pre-processing module to use 16 kilohertz frequency for sample rate of the audio files that we generate internally because we found some inconveniences with trying to utilize 44.1 kilohertz when trying to pad our audio files. We expanded the microphone interface to add a WAV file generation. Since it's not natively supported on Android via standard APIs, internally they use 3GP or AAC, but due to the nature of how MEL spectrograms are typically generated on the audio computation side, which is WAV files, we require the implementation of a new interface for our microphone. And finally, we had a modification to the chord droid existing chord library class to expose the internal representation of chords, which is used to translate chords from diagrams to the ASCII tablature notation we use internally to for representing the tablature for our users.
Thank you, Alejandro. And now for the project difficulties, the biggest of these being a poor mismanagement of the Gantt chart, which led to a reevaluation of the first sprint and the sprint 3 taking longer than expected. A contingency action was that a couple of tasks were merged between sprints 1 and 2 and between sprints 3 and 4.
Expanding upon where John ended, we go into project impact. So here we see the different types of impact that our project had in the market, economy, ethical and legal aspects. So first and foremost, we go into the economic. We see a savings of time for teachers or instructors of instruments to better focus on other areas inside the classroom. In the market aspect, we see the expansion of musical instrument into enthusiast base, thanks to a lowering of the entry-level barrier and tailoring tastes. Moving into the ethical side, we see the upholding of the privacy of users by storing every generated file locally and not transmitting any data to servers. Maintaining integrity as a service and to our customers. And finally, we move into legal, where we say we stay within the fair use laws when describing tablatures, because we know from previous cases with other companies such as guitarchords.com, where they had some problems with copyright holders for songs. They got into trouble with these companies and they got sued because of the for-profit nature of their approach. And in that regard, we try to stay on non-profit. We don't ask for any money. We just generate them automatically for free for the user. So in conclusion, we can see some of the results of our project moving forward, and we will go into this project summary first. So for the project summary, we had the deliverables. 100% of deliverables were delivered to the client and are pending approval. The products of a cost-effective Android mobile phone application that can generate tablatures given an audio file or audio input by the user. And the impacts, a combination of social, market, environmental, and economic impacts were achieved thanks to our product now existing in the market. Other achievements include the better time management and work ethic, how to work in Android Studio, and some difficulties include the ineffective task handling for certain parts of our Gantt chart. The next steps for this project include the improvement of the general user interface from user feedback, adding support for more chords, adding support for different instruments, and more chords even still. And some of the lessons learned include the asking for help from mentors and advisors with specialty in the field, some time and risk management strategies, and communication being essential part of our project. And with that, we'd like to close off by opening the Q&A section for all of our viewers right now and trying to clear up any questions that may come. And we'd like to thank you for your attention, thank you for the time, and we hope you have a wonderful holiday coming forward.